Let's see another problem of the lead code. It's a product of array except self. This problem looks very easy, but we need a proper technique to solve this problem. This problem has been asked many times in a Facebook also. So let's try to understand this problem, and then we'll come and see the code here. Because for now, if you see the code, it doesn't make sense like what's happening, but there is some logic for this code. We understand that, and then we'll come back and see the code. Okay, so it's saying product of array except self. So how to solve this? So in this case, this is the input, and if you ignore this input, first input, like you're saying except self, so ignore this, and then if you multiply, then it will be 24. So that's why 24 comes here. And in this case, if you ignore this and multiply others, then it's a 12. And ignore this, then 2 into 4, 8. Ignore this, and 2, 3, multiply 6. So this is the input, and we want this output. So how we can do this? So one of the easiest way is, we just multiply all the numbers. So 2, 3, 6, 4, 24. So once we get 24, then iterate this list, and we divide, like iterate this list, and in another output variables, what we can do, we divide 24 by 1, then we'll get the 24. And then again we divide 24 by 2, then we'll get 12. 24 by 3, we'll get 8. 24 by 4, so we'll get 6. So this is the simple way we can achieve this. But here, if you see, somewhere it's written that we cannot use the division operation. So it's saying, okay, you must write this algorithm that runs in order of n time and without using the division operation. So we cannot use the division operation, so that cannot be solution. So another solution can be, we can use two for loop. In a one for loop comes here, and then another for loop, you can multiply all those things and put the result, but that is order of n square. So that's also here, it's mentioned clearly, you must write an algorithm that runs on order of n time. So we cannot use that way also, the for loop. So how to solve this problem? So for this, we need to do some pre-processing, and we need some proper technique to solve this. So let's try to understand what is that proper technique. So let me copy this thing and go to another screen. And this is very much important to understand. Let's say it's a 1. I can say this is an array, and 1, 2, 3, 4. So we can have one prefix. We can have like one more array of the same size, then we can call that's a prefix. And here we can do like in a multiple pass. It's not like for within a for, but you can use one for, then use another for after that. So that is different pass we can do. So in a one pass we can prepare the prefix. So prefix is nothing but here 1, and if you come to this place, then 2 into 1 is a 2. So this 2 into 1 till here is a 2. And then again, if you come here, 3 into 2, 6. And if you come here, so all together it's a 24, right? 2 into 3, 6, and into 4 is a 24. So that is the prefix. So just we are multiplying, the prefix, that means whatever is before this, we just multiply everything. So 1, so 1 before this, 1 into 2, 2, whatever is the number, just multiply this and put it here. So in a one array called prefix, we can store this result, and then you can prepare the postfix. So next time we can iterate from end, like from here, and this is the 4, so we can put the 4 here. Now we can come here, so 3 and 4, 12, so we can have 12 here. Okay, and if you come here in the 2, then 3, 4, 12 and 2, 24, so we can have the 24. Right, okay. If you come here, then 2 into 3, 6 into 4, 24, again that's a 24. So we need another loop, and in that loop we have another variable also, and in this variable we calculate the postfix like this. So this is very easy, to find the prefix and the postfix. The next thing is in a output, that's the output, and here we want to put all the result, the final result. So in this case, in another pass, in the third pass, we can run this loop, and we can use the formula like the prefix and the prefix into postfix, and that is the answer, and that will be the final result we'll get. So prefix and the postfix. So when we say for the 1, when we iterate through this array, and when we say 1, for the 1, what is the prefix? So we'll see before 1 there is any item? No. So if there is nothing, then the prefix is just 1. We consider if there is nothing, then we say that prefix is 1. Okay, so there is nothing before here, so that's the prefix is 1, multiply by postfix. So for this, what is the postfix? 24. So from this array, this is the postfix. So from this number before, if there is something, take that, and if there is nothing, I consider 1, and then after 1 in a postfix with something, so we'll find 24. So 1 into 24, 24. So that is the first value in the array. Now when we come to this place 2, then we'll find out what is the prefix. So prefix is 1, and what is the postfix? It's a 12. So after this 2, it's a 12. So 12 into 1, 12. So we can have 12. Again for 3, what is the prefix? Is 2, and what is the postfix for this? So 3, so 2, and the postfix is is something wrong here. Let me see here the number we're not getting correctly. Okay, for this 2 and the postfix, this one also comes 12, and that doesn't look good. We'll see again, we'll come back and we'll see there may be some calculation. I put the wrong calculation. But for the 4, there is no postfix, but there is no postfix, but there is a prefix, and the prefix is 6. So this portion is good, this portion is why this is wrong. Let's calculate once again. So 1, 2, 3, 4, and we'll calculate the prefix. So 1, and the 2 into 1, 2, and then 3 into 2, 6, and then 2 into 3, 6, and for 24. This is the correct. And from here, postfix is 4. If you come here, 12, and this is 24. This is correct. And then again in the output for this, there is no prefix, so we have the postfix. So we got the 24. I put the 24 for the 2, and there is a 1 is prefix, and 12 is a postfix. So 1 into 12, 12. So that's good. For 3, the prefix is 2, and the prefix for this 3 is 2 here, and the postfix is 4. Oh, okay, so that's good. I think our calculation is wrong. So this is 4 and this 2, so this should be 8. Okay, so now I think we got the right result. So for this 2, 3, 6, 4, 24, and for this 2 is a 3, 4, 12, and for 3 it's a 2, 8, and the 4, 2, 3, 6. Okay, so this is our output result. So let's see the code. Let's see the code for this, how we prepare the prefix, postfix, and output with the same logic here. So if you see the code here, so that's code is in product accept self 2 function, and there is another improved version, so I'll talk about this also later, but this is product accept self 2. Okay, so I declare here three variables, left, right, and out, and the size is it's a length of nums, and then there's a one pass for the prefix. I'm saying here the left, and for another pass, second pass for the postfix, I'm saying here right, and then third pass to calculate the result on the out folder. So here in this variable we are starting with this 2, 3, 4, starting with this, and in the left 0, in the first item will be just nums 0, that is 1. So the first item is always 0, just put it here, and then left I, so left I is that is on the second item in a left, or there's a prefix, and the second item is, it's saying left I minus 1. So left I minus 1, so in left I minus 1 we have already a 1 into nums I. So nums I is the current number, so we multiply that and put that in a this left or the prefix. In the similar way we have another for loop, and now this time this 4 we can put that in a last of this right. So the last of right is the nums minus 1, where we can put nums length nums minus 1. So that's item. In a right item we put the right value, that's a 4, and then we can start our iteration from this 3. So that's why I'm saying I equal to length num minus 2. So num minus 2, it will start from 3, and we are preparing the postfix, that is right. And in the right I, so right I, that means index 1, that is second item in a right. What we do, right I plus 1, so that is the 4 into nums I. So nums I is this 3, so 4 into 3, 12. So you can put that in a right I here. So in this way we can calculate this right or the postfix value, and then our formula is we need left I minus 1, right I plus 1, and multiply and put that in a out. We are also checking if it is I 0. So when we start from here and I 0, so in this case the prefix is 1, so that's why we do not have to multiply with the prefix, but we just need right I plus 1. And here also if it is the last item, if it is the last item, and then in that case there is no postfix, so just we need the prefix, so that's why we put the prefix. So that's the exact logic, whatever we discuss, I just put it here. But it had said another improvement, can you solve this problem in a order 1 extra space complexity? Here we are using the 3 different space here, left, right, out. So that's additional space we are using, but they suggest here, can we use the order of 1 extra space complexity? That means without additional space. Output array doesn't count as extra space, so this output array doesn't count. So in that case they're saying like, is there any way to remove this left and right? So how to do that? So let's try to understand that, and again we'll come back to the solution. Okay, so we know we have already calculated this prefix and postfix, and we know this logic here. Okay, so actually like we need to do this thing to remember some of the like prefix and postfix on a paper, but actually when we solve this we just need one output variable, and let's see how I'm doing here. So array is 1, 2, 3 and the 4. Okay, and in output, so in an output, what I'm going to do in a first pass, in an output, I'll put all the prefix of the prefix of these numbers just below of this. So what is the prefix of 1? So there is nothing, so that means prefix is 1. What is prefix of 2? So 1, so I'll put 1 here. And then what is the prefix of 3? So 3, that's 2, so I'll put the 2. And what is the prefix of 4? That's a 6. So this prefix I can have the logic, and based on that logic I can prepare the prefix, and I can put that prefix in output. So here you can see I have put all the prefix. So what is the, so if I see this picture here, and if I put what is the prefix of 1, we have to see the left side. What is the prefix of 2? We have to see the left side here, that's a 1. What is the prefix of 3? See the left side, left of this, and come here, that's a 2. But in this case we iterate this loop and iterate this array, and we calculated the output, but when we calculate the output we just put all the prefix below. So if I say what is the prefix of 1, then we don't have to look at the a. So and so in this, that's the 1. If I say what is the prefix of the 2, I don't have to look at left, but I can say prefix of 2 is 1, prefix of 3 is 2, prefix of 4 is 6. That's just valid, right? Prefix of 4 is 6, so I put it here. Okay, so that's the output we got here. The next thing is, still we have the same formula. We have to multiply the prefix to postfix. So again the next pass will start from the end, and for end, and we'll see that okay for the 6, so 6 is, or the 4, yeah, so for the 4 what is the prefix to 6, and so we need to multiply this prefix to the postfix. So what is the postfix for the 4? There is nothing, so just put the 6 here, and then we'll come to this place 3, and then we'll say what is the prefix 2 into what is the postfix. So postfix for 3 is whatever is the right side. In the right side is a 4, so 4 into 2, 8, so I can put it 8. Okay, then I will come to this place. I will say what is the prefix of this to 1, and what is the postfix. So 3 into 4, 12, so 12 into 1, so 12, so I'll put it 12. I'll come to this place. What is the prefix? It's a 1, and what is the postfix? It's a 2 into 3, 6 into 4, 24, so I can put it 24 here. So that's the solution. So in a one variable, this output extra space, but they are saying output won't be considered as extra space, but with output variables we did the 2 pass and we calculated the result. So let's see the most optimized solution here. So this is the most optimized solution. Here I created one out variable, and in out variable I put the L, just one pointer, L is equal to 1, and out 0 equal to 1. So out 0 and there is a 1, and then I'll start the iteration from this 2 here, I equal to 1, I less than, and then L into, we calculate the L into whatever is this nums I minus 1. So nums I minus 1 is 1 into whatever is in L, just multiply and put that 1 into 1, and then out I can put the L. So we can calculate in the first pass, we can put all the prefix just below the number. So we can see that algorithm, and then based on that we can try this loop. And then another pass, we need to multiply L into R, so that is prefix into postfix. So the first thing, I'll make it R equal to 1, because on the right side, for the right side postfix is nothing, so R is equal to 1 here, and I'm starting with this place. So the traversal is from the end, so end from here, so 3, and then I say that R equal to 1 into nums I plus 1. So num I plus 1 is the 4, so 1 into 4 is a 4, and then out I can put the 4, so 4 into R. Yeah, so out I is, so in out I, what will be the value? So in out I you already put that 2, and this is the 4, so 4 into 2, 8. So in this way we calculated this logic. So yeah, so this is all about the logic. You can try this, and you can try and debug this, and you will get the idea. So the main thing is we need to import, main thing is we have to remember the technique, how to do this thing with the postfix and the prefix. So the same solution, I have just put in a Java, but in a Java I have put the most optimized one. So this is the most optimized one. One pass, we are calculating all the prefix and putting just below of the array, and in the second pass we traverse from the right and calculate the final result here. So that's all for today. Thank you.